Hi, once again, Mr. Wakefield here, and we're doing the beginning of chapter 9 now. And this chapter is mainly dedicated to radicals, and radicals are usually associated with square roots, but there's other types of roots as well. But the radicals are related to roots of different kinds. Mainly, though, like I said, mainly square roots. So anyway, let's jump right into it here and learn about what a square root is. I'm going to jump right into the first problem so that you can see that. But just before I do that, though, let me go back to a list that I showed you back in chapter 7. It's really going to help us here in this section and in this chapter. We had this list of perfect squares and perfect cubes. We did these problems back when we factored the two-term polynomials, like when we did like a squared minus b squared and a cubed minus b cubed and those formulas. This really helped us. It's going to help us here too. As you know, 1 is the same thing as 1 squared. This is the same thing as 2 squared, 3 squared, 4 squared, 5 squared, and that's where this list came from. It's all the whole numbers being squared. 1 squared, 2 squared, 3 squared, 4 squared, and so on. This over here is the same thing, only it's cubed, where it's 1 to the third power, 1 cubed in other words. 2 to the third power, 3 to the third power, 4 to the third power, 5 to the third power, and so on. And so we know that these numbers are equal to, when you take a whole number to the third power, that's why we call them perfect cubes in the first place. But what if we went backwards now? What if I now started with 27 and I said, what number do you have to cube to get that? And we've actually done that. We've actually answered that question before anyway. Let me show you, just to remind you of the fact that we answered that question already. And it's going to be a very similar thing today. See how here I said we had 36. This is back in 7.4, okay? And we were factoring 36, and I said, hey, what goes in here? Well, 6 goes in there, okay? What's being squared to get 36? What's being squared to equal 1 up here? Well, it's 1, and that's why I put 1 inside this little parenthesis here, okay? What's being squared to get 9? So I had to put a 3 in there. That's exactly what we're going to be doing here, although there is some additional technical stuff you got to watch out for, though. Listen out for that. But that's what square roots are basically about. The one thing about square roots, and I'll explain why this is the case in a minute, is that when you have a radical, and when you see a radical like this, that's a square root, okay? But, and here's where we got to be careful. Look at problem F down here. See how in problem F you have a little 3, okay, inside of this V shape right here. You got the 3 sitting on the edge of it there. That's the cube root, okay? Not to be confused with the square root. We'll be very careful here in this video to be able to tell the difference. We'll explain that. The difference between a square root, which is when you have one of these radical symbols here that does not have a little number here, okay, a little number at the edge of the V there, whereas with a cube root, it's the same radical symbol here, but then it has a little 3 there at the edge of the V shape there, okay? So if there's no number on the edge of the V shape there, it's a square root. If there is the little 3 there, it's a cube root. There are other types of roots that exist as well. I don't believe we're going to see that here. I'll have to double check. If we do, I'll go over it carefully. But I don't think we're going to see that in this class for the most part. We're just going to look at square roots and cube roots. When you move on into Math 71, you'll see where this number, this little number right here, changes to a 4 or maybe even a 5. And that would be different. That would be like a 4th root and a 5th root, as they call it. But in this class, it's mainly just square roots and cube roots, okay? So let's jump into it now. With square roots, you got to be careful because basically how square roots work is like this. Just like I showed you in that 7.4 worksheet just a moment ago, you want to know what goes inside of here so that when you square it, and use a parenthesis to make sure you get the correct thing, what number goes in there, okay, in order to get it to equal 16. Now here's the issue, though, that we got to watch out for. With square root radicals, okay, the answer has to be positive. Because let's face it, you guys, I could put a 4 in here and it would work. But I could also put a negative 4 in there and it would work. Okay? So how do you know which one is right? Are they both right? The answer is that only the positive one is right. So let's make this clear here. Okay? In fact, I mentioned this up here. When you have a radical, a square root radical, it is just equal to the positive square root of a. Positive only. Okay, if you want a negative square root of a, that's a separate thing here. We'll talk about that with the negative sign and all that. But if you're just trying to figure out what the square root radical is equal to here, it is only equal to the positive answer. And so when you are given just a radical, no negative in front of it or anything like that, okay, again, we'll see that type of example over here in problem D. Okay, don't worry, we'll go over that. But if you just have a square root radical, okay, you only want the positive number so that when you square it, it's equal to that number underneath the radical. That's what a square root radical is. It is the positive number so that when you square it, it's equal to this number that's underneath the radical. And so the answer must be 4. But again, don't say negative 4, okay? It's just, a square root radical is just the positive square root. In other words, the positive number, so that when you square it, it's equal to that number underneath. Let's try that again. We have just a square root radical, no negative in front of it like in problem D over here, okay? Just a square root radical. So what they're asking is they are asking, what positive number do you have to square so that it'll be equal to the number underneath the radical? Well, we know that that's 5, right? And so the answer is 5. All right. Here's an interesting one. Again, this is just a square root radical, no negative on the. I know there's a negative inside, but that doesn't count. If there's no negative outside, if it's just a square root radical with nothing outside of the radical, that means that they are just asking for the positive number so that when you square it, it's equal to negative 1. What's wrong with that statement right there? Okay, what happens when you square something? It's never going to be negative, is it? Okay, if I put 1 in here, if I put 1 in there, it's going to be equal to positive 1, isn't it? But if I put negative 1 in there, it's still going to be equal to 1. No matter what you pick, and you had to pick a positive thing anyway since this is a square root radical, but I'm just making a point that even if you did pick negative 1, it still wouldn't work. You can never square anything, at least not in the world of real numbers that we look at here in Math 51. In Math 71, you'll see this thing called imaginary numbers. That's a little bit different. Don't worry about that right now. We're just in Math 51 right now. In the world of real numbers here in Math 51, there's no way, you guys, that you could square anything. It doesn't matter if it's a positive or a negative. If you square anything, it will always be equal to a positive number, or at the very least, it could be equal to 0, but it could never be negative. Let me say that one more time. If you square any number, no matter what it is, it can never be negative. And so because of that, there's no way that I could find an answer here when it's supposed to be equal to a negative 1. And so what do I say? Well, notice what I just mentioned. I said in the world of real numbers, that's not possible. But in Math 71, you'll have this thing called imaginary numbers. And so for that reason, the way I'm going to write out the answer is like this. Not a real number. Okay, meaning that later on in Math 71, you'll see imaginary numbers that could make this work, and it will. But whenever, let's just make this simple here. Whenever you have a square root radical, you guys, I'm not talking about cube root radicals. As you'll see, that's different. When you have a square root radical, because you can never square something to get a negative, that's impossible here. If you have a square root radical with a negative number underneath, it's not a real number every single time, because it's impossible to square something and get a negative. Okay. Moving on to problem D. First of all, what do I do with this negative? Whenever you have a negative at the beginning of a problem, the beginning of any math problem, and it's immediately followed by what we call a grouping symbol. An example of a grouping symbol is a radical or a parenthesis or an absolute value, okay? I know we haven't seen absolute values, and we won't right now, but the point is that when you have a negative sign at the beginning of the problem followed by a radical, that negative sign means -1 times the radical. And that's important because in order of operations, and we're going to do order of operations here because there's no variables, and so in order to figure out what something's equal to and there's no variables, you normally do order of operations. Order of operations says that radicals come before multiplication. So now we know exactly what to do. We need to figure out what this radical is equal to first, and then we multiply that answer by -1. So we still need to figure out what the square root radical is equal to. It's just that we multiply by -1 after that when you have a negative in front of the radical like that. Okay? In other words, if your entire problem, you guys, and you see the same thing down here in problem H, if your entire problem is a negative sign followed by a radical and there's nothing else, just those two things, the negative and the radical, then you set it up like this. You do the radical first, and then you multiply by -1. The radical is going to be the number that goes in here, isn't it? Because a square root radical means the positive number that fits into this equation here, inside the parenthesis. What number do you square, and it has to be positive, what number do you square to get it equal to 169? That is 13. 13 squared is 169. And so that means that this is equal to -1 times 13. Okay, so the radical is equal to 13. Okay, and then the final answer then is -13. So yes, I know that the final answer was negative, and I know you might be thinking, wait a second, I thought square root radicals were only supposed to be positive. That's still true. Remember, the radical was equal to +13. It's just because the negative was outside of the radical. That's what made the whole final answer negative. But it's still true like it was before. No contradiction here. The square root radical itself was equal to a +13. Okay, so that's still true. It's just that since we had a negative outside, it made the whole answer negative. Okay. But the radical is still positive like we talked about. Okay? All right. So, square root radicals are equal to the positive number that you square to get it equal to the inside of the radical. This time we have a fraction, right? No negatives on the outside or anything like that, so we just ask ourselves, what number do you square to equal the inside of the radical? Okay, well, when you have fractions, you guys, and we'll see later on in the chapter, it doesn't always work out this nicely, and we'll have a method in that case. But if it's true that both the top and the bottom of the fraction are numbers that are on this list here, and yes, 100 is on this list, I just need to extend my list to the next number there, that's all. 9 squared is 81, so 100 would be next since that's 10 squared, right? Okay, so if both the top and the bottom is on this list, then there's an easy way to do this. I'll show you that. Okay, it's the same thing here in problem 3 that I'm going to ask you to do in a minute here. 36 and 49 are both on the list here, and so you'll be able to do the same method on number 3 that I'm about to do here in problem E. Okay, and what is that method? Well, as you guys know, when you square a fraction inside of a bracket, you square the top and bottom. So it would make sense then for us to ask the question, okay, what do you square to get 1? And what do you square to get 100? Wouldn't that be 1 and 10? And so wouldn't it make logical sense to pick 1/10? Just make sure it's a positive fraction, positive 1/10. Okay, wouldn't it make sense to pick 1/10? Okay, because if I square the 1 and square the 10, just like I did in the exponent rule section back in chapter 2, exponent rule sections, okay, we learned that you square the top and bottom when it's written like this. Okay, and so it matches up perfectly with this. And so therefore the final answer here is 1 10th. The positive number, in this case the positive fraction, that you square to get the inside of the radical. Okay, we'll look at cube roots in just a minute. Let's make sure that you've got this whole concept of the square root radicals down first, okay? One more note here. We didn't talk about the square root of 0, but I think you can imagine what that's going to be, right? What do you square to get 0? I'll let you answer that question. I'll put the answer up here when you hit the play button again. But please try 1 through 5. Do not do 6, 7, and 8 because those are cube roots, okay? Just do 1 through 5. Let's make sure you understand those problems, okay? Then we'll talk about cube roots after that. So hit the play button when you're done, and we'll take a look at those 5 answers. Okay, let's take a look at those 5 answers. In number 1, what number do you square, and it's got to be positive since it's a square root radical, to get 64, which is the number underneath? Since 8 is the correct answer there, therefore 8 is equal to the radical. Okay? Again, that's number 1 there. There we go. What number do you square to get 225? And again, it's got to be positive. 15. Okay. And so therefore the square root of 225 is 15. Your calculator will help you figure out those things. You could put that in there. You could say, hey, and I'll show you how to figure out square roots on your calculator here anyway. But 15, if you put 15 times 15 in your calculator, will be equal to that. What do you square to get 36 over 49? Well, just like this problem up here, because of the fact that 36 and 49 are on the perfect square list that I showed you a few minutes ago, you just have to figure out what numbers are being squared to equal 36 and 49, and you make a fraction out of it, just like I made a fraction out of 1 and 10. So wouldn't that be 6 and 7? And just make sure that fraction is positive. It is. And so therefore the answer then would be 6/7. What do you square to get 0, you guys? 0, right? 0 times 0 is 0, right? So that must be it. Now, 0 officially is not a positive number, okay? But it's still okay. Because the main thing, I keep on saying that it's got to be the positive number. For 0, that's an exception, all right? The important thing is that it can't be negative, all right? Your square root radical cannot be equal to a negative. I just say positive because 0 is the one exception to that. So, yes, a square root radical could be equal to 0 if there's a 0 underneath. That's the only time it's going to happen. But the main thing is that a square root radical cannot be negative. It could be positive, or in this very rare case, it could be 0. It just can never be negative. But I say positive all the time since 0 is very rare. But just remember 0 is also possible, but only if the square root radical has a 0 underneath it. That's the only time that it happens. Okay? Number 5. Again, when you have a negative in front, you want to separate it like this. When you have a negative and a radical, if you just have those two things, I'm not talking about a bigger problem, but just when you have a negative and a radical, write it like that. Figure out what the radical is, since radicals need to be computed before multiplication. And then once you figure out the radical, you then multiply by -1 and you're done. So what is the radical? Not including the negative. That's a separate step coming up here. The radical 16, okay, that is going to be the positive number that you square to get 16. So that would be 4, wouldn't it? Then you multiply by -1. The final answer actually is -4. Okay. All right. Now, I'm not always going to call this a radical moving forward here, all right? Traditionally, as other teachers do, and also the textbooks do as well, what they did, and so I want to be consistent with that so you don't get confused when you have other teachers or you have other textbooks and stuff. When you see just a square root radical, you guys, not a negative in front of it, but just the radical only. That's it. Nothing outside the radical at all. that is referred to traditionally as the square root of a, or whatever the number is underneath. Okay. Officially, it's the positive square root. Officially, it's equal to the positive square root when you have just a square root radical. We know that now, but we usually leave out the word positive, okay, just to let you know. So, for example, the square root of the radical, the square root radical here of 16, officially that is equal to the positive square root of 16, and that's why we pick positive 4. But the way they usually say it is the square root of 16. So when they say the square root of 16, what they're really talking about, you guys, is they're talking about the positive square root of 16. Okay, so this is the square root of 16. It's just short for positive square root of 16. This is the square root of 25. Again, it's short for positive square root of 25. Okay, this would be, if it existed, and it doesn't, it's not a real number, but it would be the square root of -1, same thing as the positive square root of -1. This right here would be -1 times the square root of 169, which is the same thing as the positive square root of 69 times -1. But the -1 times the square root, okay, that actually comes out to be a negative answer, since the square root is supposed to be positive, but then you multiply by -1, it's always going to be negative. And that's the reason why when it's written like that with the negative in front and then the radical, we call that the negative square root. But that does not change the fact that, as I already said, it does not change the fact that the radical is still positive. Okay, and so the way you word that is you word that -1 times the square root of 169. Okay, so just wanted to make sure you understood from the standpoint of words how these things are said. Okay, so let's go ahead and move on here to the cube roots. The cube roots it's the same idea, but now you don't pick the positive one only. In fact, don't do that. You'll see why here in a second. The cube roots work completely differently. Let me just jump right in the first problem, and you'll start to see why here, and then we'll go over it a little bit more. So with the cube roots, you ask yourself, what's being cubed to equal the number on the inside? But it doesn't have to be the positive. It could be negative in that case. So with the square root radicals, it's got to be the positive answer only. Okay, partly because if the number underneath the square root radical is positive, you could theoretically have two answers, 4 or -4. So it was chosen when whoever invented square root radicals, they chose that it was going to be the positive answer. Okay, because otherwise it could be either one. But with cube root radicals, though, it could be, what's going to happen is there's never going to be two answers. There's never going to be, like right here, either 4 or -4 would work here officially. Okay, so we had to, it was chosen that it would always be the positive answer that would be the answer. But with cube roots, there's always going to be one answer, you guys. There's never going to be two possibilities like 4 and -4. There's never going to be a situation where there's no possibilities, okay? I'll show you that here. Even with negatives, there's always going to be one answer. That's the thing about cube roots. There will always be one and only one number that will work inside of this little bracket right here. Every single time with cube roots, it's a lot simpler. Okay, with square roots, sometimes you got two possibilities, 4 or -4. Okay, so we know that with square root radicals, it's always got to be the positive choice. Sometimes there will be no possibilities because it can't equal the negative. All right, and that's just how square root radicals work. They're a little bit more complicated. But with cube root radicals, there will always be only one choice that goes inside of this bracket, and so you just got to find it, and that will be your answer every time. So what one number fits in there, you guys? Isn't it true that 4 to the third is 64? Oh, but hey, what about negative 4? No, negative 4. If I did negative 4 to the third, you guys, let me write that off to the side here. I'll show you. If I did negative 4 to the third, wouldn't that be equal to negative 64? That's not the number that's underneath the radical. Positive 64 is underneath the radical. So you can see here that unlike in problem A, where 4 and negative 4 would both fit inside of the bracket, with cube roots, only one number will work. And then if you make that same number negative here, it would yield a totally different number as an answer, and so it wouldn't match up with the positive 64 that we have in this problem. It would equal negative 64. Okay, so that's what I'm saying. There's only going to be one number that works when you do the cube roots. Okay, so you just got to find it. All right, and there you go. So when you have a negative number underneath the cube root, there is going to be an answer. Cube roots will always have an answer, you guys. You'll never have this not a real number stuff going on. It will always have an answer. Okay, the reason why is because when you cube something, you could get a negative answer. Okay, when you square something, you could never get a negative answer, as I mentioned up here in problem C. But when you cube something, you can and will get an answer every time. What is that answer here? Wouldn't it be negative 2? Because if you multiply negative 2 3 times, negative 2 times negative 2 is equal to 4. But then if you multiply it a third time, 4 times negative 2 would be equal to negative 8. So it's just different when you take something to the third power compared to when you take something to the second power. So since negative 2 fit inside that bracket, the answer there is negative 2. Okay? And finally here in problem H, when you got a negative in front of the radical, just like we did before, that means negative 1 times the radical. You figure out what the radical is equal to first. Sorry about that. There it is. Okay, you figure out what the radical is equal to first, which means that we need to what? We need to figure out what number goes inside of that bracket so that it's equal to 125. Okay. And then we then multiply that answer by negative 1. Well, as you guys know, from when we did perfect cubes, back in chapter 7, all right, we got 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so 125 is the 5 cubed, isn't it? And so the 5 goes there. And so therefore this is, the radical is equal to 5. Okay? But then when you multiply by negative 1 to finish off the problem, the final answer is negative 5. So if you've got that negative on the outside, okay, you got to remember to multiply by negative 1 after you figure out the radical. All right, because that's just how it sets up when it's written like that. Okay, so please try problems 6, 7, and 8. Very similar problems there. And with cube roots, you'll always just have one number that fits inside of that bracket. Again, you just have to figure out what it is. Okay, so try those 3 problems, hit the play button, and then we'll do some calculator work. So go ahead and pull out the calculator that I asked you to have for the semester, though, as I talked about in the syllabus. Okay, pull that out, all right. I know that there's different types of calculators, but I'll be looking at the 2 main types, of course, let me know if you have any questions if it's still not giving you the right answer. All right, but go ahead and pull out that calculator that you have, and then we'll take a look at some calculator problems here, I and J down here, after we finish up 6, 7, and 8. Okay? So hit the play button after you're done with those 3 problems, and we'll take a look at our calculators here. Okay, so let's take a look at 6, 7, and 8. Again, with cube roots, there's always going to be just one answer. One number that goes inside that bracket that makes this statement work. What number to the third power would be equal to 27? What would make that work? Only 3 would work, right? Negative 3 would not work because negative 3 to the third power would be negative 27. Not the same thing. It has to be positive 27. So there's one and only one possibility. Just figure out what it's equal to, and then that's what the cube root is equal to. Okay? What number do you take to the third power so that it's equal to the number on the inside here, negative 64? That would be not 4, but negative 4. Remember, 4, as we saw up here in problem F, 4 to the third is positive 64, negative 4 to the third, because when you multiply a negative number 3 times, it's going to be negative. That's always true. You multiply a negative number 3 times, in other words, to the third power, it's going to be equal to a negative number every time. So it makes sense that that would be negative 4. Okay? And then finally over here, and I see here, I just noticed that it's the same exact problem as I had in problem H. I should have changed that. But just for practice, I'm going to do it again. Okay, it can't hurt to practice it. Again, when you have a negative outside of the radical, a negative and then a radical, and that's all you have, you write it like this. You figure out what the radical is equal to. Okay, it's going to be equal to 5, as you can see there inside the bracket. And then, since the radical is equal to 5, we then multiply that by negative 1 after that, just like we've been doing. And again, the final answer is negative 5. Okay, so pardon me for asking you to do the same problem twice there, but it couldn't hurt to practice a little bit more. Okay, so that's why we did it again. All right, to wrap up this section, you guys, I need you to pull out one of the calculator that I asked you to buy. I gave you different options, okay? But out of the options that I gave you, it don't necessarily have to be one of these two calculators, although these are two of the calculators that I had on the list on the syllabus. But all the calculators that I had on the list all fall into two categories, basically. It's either a one-line calculator or a two-line calculator. Let me explain what that means. A two-line calculator, let's say, for example, I do something simple like 5 times 3. If I type in 5 times 3 into my calculator here, okay, I just typed it in down here. When I hit the equal sign, it actually puts the answer on a separate line right there. So the problem is on the top line, the answers are on the bottom line. That's a two-line calculator, as they call it. This calculator, however, a little bit more of an old-fashioned model, but that's fine though, okay, because it works. If you do 5 times 3 on this calculator, okay, if you do 5 times 3 on this calculator, see how it gives the answer on the same line, and then the problem itself disappears when you get the answer, okay? Because it's all on the same line. So it didn't have room for both the problem and the answer. Whereas in this one, the problem and the answer appear on two separate lines, so you can see them both. Irregardless of what kind of calculator you have, okay? As long as it's a scientific calculator that is one of the ones that I approved, okay? What will happen is that you will be able to do these next two problems, but you just need to listen here to make sure that you are doing the steps correctly, because these calculators are different, okay? If you're doing, look, for example here, in problem I, it's a square root of 5. Now let's back up here, okay? 5 is not one of the numbers on this list, right? We know what the square root of 4 is. We know what the square root of 9 is. We know what the square root of 16 is. We've done all that. We know how to figure out the square roots of these numbers. But what happens if it's not one of these numbers? Okay? If it's a whole number and it's not one of these whole numbers here, like if it's 5, 6, 7, 8, 10, 11, 12. In other words, if it's one of the whole numbers that's in between these numbers, but it's not one of the numbers on the list, then what happens is that you end up getting this weird answer. It's called an irrational number. It's a decimal that covers your entire calculator screen, all right? Which actually means that it goes on forever. It's just that your calculator screen had to stop it at the end of the screen. It couldn't go any further. But it also doesn't have a repeating pattern like a lot of decimals do. Okay, so that's what they call an irrational number. And when we have an irrational number, the only choice that we have in order to be able to write out an answer is to round it off. Don't ever round off answers unless the directions ask you to. Okay, sometimes the Homework won't do that because sometimes the textbook doesn't do that. But on a test question, you guys, please don't ever round off unless you're asked to. If you are not asked to round off, you are expected to give an exact answer without rounding off or cutting off part of the answer or anything like that. Okay, I just want to make that clear. But in the case of an irrational number, I would always ask you to round off because it's impossible to come up with an exact answer. The decimal goes on forever, and you can't possibly just keep on writing a decimal forever. Okay, and so that's what happens with these problems. The square root of 39 is the same thing. 39 is not on this list right here. Okay, so it's going to do that same irrational thing. All right, with a big decimal that goes on forever, you got to round it off. Here's how you do it. For square root of 5, okay, if you're using a one-line calculator, this is what you got to do. You got to hit the number 5 first. Then find the square root button. And on here, it's this one right here. You can see that right there. Okay, so hit that button, and then you don't even need to hit the equal sign. It already does tell you what it's equal to. If I round that off to the nearest tenth, like the problem asked me to do, that means one decimal place after the decimal point right here, which you can see is in between the 2 and the 2 right there. You got a decimal point right there. Okay, there it is right there. And so since the next digit is less than 5, it's going to round down to 2.2. 2.2. Okay. How would you figure that out if you had a two-line calculator? It's the opposite way. With a two-line calculator, what you normally do, and again, let me know if it doesn't work on your calculator, but what you would normally do if it was a two-line calculator is you would first of all hit the radical button before the 5. So you enter it the opposite way. Now on this calculator, let me zoom in. On this particular calculator, the square root button is actually above the x squared button right here. Okay, let me use a different color so you can see better. There it is. So there's the x squared button, and then the square root button is above that. So in order to activate something that's above a button, if you're not too familiar with calculators or you don't remember, is it's either going to be like a shift key or what they call the second key here. See how it's the same color as the things that are above the button there? So they're telling you that if you need something in light blue right there that's above the button, you hit this button first, and then you hit that button. And instead of the x squared button being activated, the square root button is activated, and you can see a square root symbol comes up on your screen. At that point, now you type in the 5. Go ahead and close up that bracket. They like to open up a bracket when they do the square root for some reason on this calculator. So any time there's a bracket opened up, you've got to close it up like that. Then you hit the equal sign, and as you can see, it gives you the same exact answer as this one was over here. Okay, it's just a different way of entering it. Okay, so whether you have a one-line calculator or a two-line calculator, you now know how to figure out the square root, okay, on your calculator. Now, how about for square root of 39? Let's do the same thing. Square root of 39. On this calculator, again, you're going to put the square root button or the square root symbol on the screen first. Okay, again, I hit the second button since the square root was above one of the buttons here. You got to hit that button to activate it. If you don't hit that button first, the x squared is going to be used instead of the square root. Not the same thing. Put 39 in there, close up that bracket, and we get that answer right there. Okay. And you can see there the decimal point is there, so it's going to be 6.2, and then since the next digit is less than 5, you round down to 6.2. 6.2. Let me write that down. If you use your one-line calculator, once again, one-line calculator, just to prove that the answer comes out the same, you first of all enter the 39 on this one, and then you hit the square root button right here. Okay, this one right here, and it will automatically give you the answer. No need to hit the equal sign. And you can see it's exactly the same answer, 6.2. Okay, so that's how you figure out the square root on your calculator. And that wraps up this section. We'll be learning a lot more about things that we need to do with square roots, including multiplying and dividing them, adding and subtracting them, simplifying them. A lot of the same things we did with fractions, it's just that now we'll be doing them with radicals, okay? And so obviously the methods will be very different, okay? But that's what we'll be doing coming up here in the next few sections of Chapter 9. So we'll see you back here for the next video, Section 9.2, at that time. So take care and have a good day.